Programming is the process of writing instructions in a specific computer language to control microcontrollers or other computing devices to perform tasks. A programming language consists of structured symbols and syntax, serving as a medium for human-computer interaction, translating human logic into machine executable low-level instructions. Common programming languages in embedded development and automation control include C++, Python, and Java. C++ is suitable for high-performance hardware control. Python excels in rapid prototyping, and Java provides reliable cross-platform support. Next, let's discuss the development process of embedded systems. This process begins with assembling and connecting hardware circuits. Once all electronic components are correctly integrated, control program code is written according to functional requirements. The next step is testing and debugging to identify and fix potential issues. If the system operates correctly, the program is then burned into the microcontroller. Finally, functionality verification is conducted to complete the development. If any stage encounters issues, debugging is revisited until the system reaches a stable and expected performance. Embedded programs are typically structured into three layers: definition layer, initialization layer, and execution layer. The definition layer includes include directives to import library files and define global variables and constants. These libraries are precompiled functional modules that provide standardized solutions, support code reuse, and enhance development efficiency. The setup function is automatically called once when the device is powered on or reset. It primarily configures hardware interfaces, initializes peripherals, and sets communication parameters to ensure stable system operation. The loop function serves as the core of the program, executing in an infinite loop to continuously respond to system requirements, collect sensor data, process it using algorithms, and generate output signals to drive the device, ensuring stable operation. Do you remember the LED blinking code from when we learned about the Arduino Uno? It makes the LED on pin 13 of the Uno board blink once per second in a continuous loop. Now, let's modify the code to light up an external LED. First, connect an LED and a 10K ohm resistor in series, with the other end of the LED connected to the D2 pin of the Uno and the other end of the resistor connected to GND. Next, change the define pin from 13 to 2 in the code. Once you start the simulation, you will see the LED begin to blink. A variable is a value that can change depending on conditions or information passed by the program. They are used to store information and can be referenced and manipulated within the program. Variables also provide easily understandable and memorable names for data. This is the format of a variable. Data types specify the kind of values a variable can hold and define the operations that can be performed on it. In this lesson, we will focus primarily on void, boolean, int, float, and char. Void is used exclusively in function declarations, indicating that the function does not return any value to the calling function. Boolean can only take two possible values, true or false. Each Boolean variable occupies 1 byte of memory. Int is the primary data type for storing whole numbers and occupies 2 bytes of memory. Functions are a way to organize code for reuse in other parts of the program or by other functions. Depending on the programming language, they may also be called methods or routines. Just like the setup and loop functions, the format for defining a function is. Note that functions can have anywhere from 0 to multiple input parameters. Software documentation represents the formal written method engineers and programmers use to describe their products and development processes. Visit the official Arduino website where you can find documentation for functions like PMODA, delay, and digital write. The documentation demonstrates how to use these functions, their capabilities, and proper implementation. For instance, the digital write function accepts 2 input parameters. As previously mentioned, functions can be designed to accept 0 parameters or as many as required. In this lesson, we systematically learned the core knowledge of microcontroller programming, including programming language selection, 3-layer program architecture, hands-on LED control, variables, and data types, as well as function definition methods, and mastered the skill of consulting official documentation. Next lesson, we will study serial communication technology, master the serial port protocol, and serial library application to achieve inter-device communication.